Hi guys, Miss Platina here, and I'm going to talk to you about a classical physics problem that's called the monkey hunter problem. Now, I don't recommend that anybody go out and try to shoot a real monkey. It's not a good idea. The government also doesn't think it's a very good idea, because when we tried to get this monkey hunter demo across the border from America, they held it up for about a month at the border. So we know with parabolic motion that if we neglect air resistance, everything is going to fly through the air in a parabola. And that's because of gravity. Gravity is pulling down on the object while it's traveling sideways. So the monkey hunter problem is if you have a hunter looking to shoot a monkey, and the monkey is up in a tree. That's my monkey. Then, where should the hunter be aiming? Now, if the monkey doesn't move, and depending on exactly how far back the hunter is, they're going to have to aim high. Because what's going to happen is after they let go of that shot, it's going to curve a little bit in the air because of parabolic motion, because of gravity. The question is, if the monkey drops straight down as the hunter is shooting, right at the exact second, where should the hunter be aiming? And the answer to that is that the hunter should be aiming directly at the monkey. And what should happen then is that as the bullet curves through the air, and as the monkey is falling, those two things should intersect at the same spot. So here's our monkey hunter demonstration. What we've got is we've got a cannon that's spring-loaded. Now this has got quite a bit of kick in it, and you can also see that it's adjustable. So we can change the angle of this cannon just by adjusting it up and down. It's also clamped to the table because it's got quite a lot of kick to it. So this cannon also has a laser sight that's plugged into the end here. It's just running off the same battery source. And hopefully you can see the laser on my hand a little bit. So what I've done is I've lined up the laser and I've followed it back and across to my monkey. So here's our little monkey. Now this guy is sitting on an electromagnet. So that means that this is a magnet that's being controlled by the electricity in the cannon. And it's set up so that right at the moment where the cannon is going to fire, this guy is going to drop off of the magnet. So it's on right now. I'm going to drop it for a second just so you can see what's going to happen by using the electromagnetic switch. So he's just going to fall off like that. So the electromagnetic switch is actually connected here at the back of the cannon. So this part of the cannon, once it fires, that's going to hit the little switch. That's for the electromagnet. As soon as it hits that switch, then the monkey is going to drop. So I just have it propped open. That allows me to take out the laser, drop in the ball, and we're going to fire at our monkey. So this is just a different angle of the same type of shot. So hopefully you can see the laser lined up on the monkey. So this is our monkey hunter shot close-up. So I'm just going to remove the laser from the cannon. And then we're going to fire. All right, so there's the monkey hunter. You can see that when we aim the cannon directly at the monkey, then the parabolic arch of the bullet combined with the linear movement of the monkey, they are going to intersect. This is, again, Neglecting air resistance. We have a small round ball. It's going to fly fairly easily through the air. We've got a small round monkey. It's going to fall pretty straight. So if we had to include air resistance, then everything would just be slightly off. It's still going to work pretty well though. Your job is to prove that this works using the numbers. So the sheet that's posted has a set of numbers on it. Actually, it mainly has a set of variables on it. And so you are going to prove using substitution, setting things equal to each other, that it does matter and that the hunter should be aiming directly at the monkey before the shot.